Now, today we're going to start a couple of problems about work, and going to start off slow because this is where everybody gets bogged down. Get my related rates out of the way. There we go. All right, some of y'all have had physics and some of you haven't. I don't really know what you had. I don't need you to tell me so. But work is equal to force times what? Distance. Okay? Everybody needs to make sure you understand that. Because when you're talking about integration, the work is equal to the antiderivative from A to B of f of x times dx. Now dx is kind of an important part here. Dx is kind of like delta x, but technically is delta x, in which in work problems it's called a what? A slither. Whenever you're talking about work, you're always going to generate a slither. In this first problem, let me just write down the problem. A heavy rope (60 feet long) weighs 2 pounds per foot and hangs over a building. And the building is always longer than the rope. I'm not going to put a 120-foot building in here because a 120-foot building has what to do with the problem? Nothing to do with the problem. So put a little asterisk right here. The building will always be longer than the rope. Okay? That way you don't put another number down in here and get it all confused. A. How much work
Facebook message
to pull the rope to the top? And B, how much work to pull half the rope up? Now draw a picture. It's not going to be real hard to draw a picture because we're talking about a building with a rope hanging off of it. So hopefully y'all can draw a picture of that. If you can't, just chalk that up as being a building. So here's the building, and you got a rope hanging off of it for 60 feet. Now, in your basic type of statics and dynamics problems, you're usually talking about vectors, but if you have a floor and you've got a 10-pound box and you push it with 15 pounds of force or whatever, the work is equal to, you want to push it 20 feet, then that's work is equal to force times distance. So work is equal to 15 pounds times what? Foot pounds times what? 20 feet, which comes up to 300 what? Foot pounds, basically. All right? The whole point of me showing you that is that you're going to take a portion of this rope and all your work problems, you're going to find a slither. And that slither is going to be called delta X, not dx. Delta X. In most of your work problems, you're going to have a delta X. And later on, as soon as you put that delta X into the integration, it becomes what? It becomes what? Dx. So technically, if this is equal to force times distance, then technically one of these is distance and one of them is force. You see what I'm saying? And the delta X is pretty much your force. And you're going to bring it up a what? Distance. Now, the integration part from 0 to 60 would be the length of the rope, A to B. Because this little slither has to travel what? All the way up. Now, you can put that slither on the bottom, right here, and you can push that slither all the way up 60 feet. You got to think like this, okay? You can't say, oh, it's in the middle, so it goes up 30. No, put it down here if you want to. Let's just erase this and put it down at the bottom. There's your slither. And you got to take that slither all the way up 60 feet. So the integration is going to be from 0 to 60 of f of x dx. All right? Now, we know that the slice is going to be 2x because of what? There's your rate right there. Think of this as a rate. Remember how we had to have a rate in the related rates problems? We had to have something. Well, technically that's your rate. Don't call it that in physics because some physics teacher at Henry explained it to do that. All right? Just kind of keep that in the back of your mind as a rate. 2 pounds per foot. 3 feet per second. You know, it's kind of like a rate. So treat it as a rate. So that means that it's going to be going in here. Right there. Okay? Now the x right here, this right here is going to be your distance, x. Now that has to be incorporated into the integration. So x is always going to be in there. So technically, this is like a rate, and this is like a distance. And then you have to carry that what? That slither all the way up this distance, right? And there is your work formula for the A part. So work it out. So, part A is going to be this part. So, what is the antiderivative of 2x? Well, that would be 2x squared over 2, which ends up with what? X squared, evaluated at 0 and 60. I'll do 0 for you. So what do you come out with? 3,600 what? Foot-pounds. Work is always in foot-pounds. All right, now you try to do B. But the problem with B is you're only going to be pulling up how much of the rope? 30 feet. You're only going to be pulling up that much rope. What's on the end of that much rope? The rest of what? The rest of the rope, right? Well, what is the rest of the rope? It's kind of like a dadgum big pail, isn't it? On the end of a rope. Why? Because it has weight to it. You got to think about stuff like this. All right? You're transitioning. You're still transitioning from algebra. Algebra, just you didn't even think about stuff like this. But now you've got a 60-foot rope and you're pulling it halfway up. So this part of the rope right here just basically turns into a what? A big what? A big weight. If you never thought about that, you're probably sitting there going, "Never thought about that." It's not. It's just a big weight. So just put a big weight here because that's what it is. Okay? Now you're going to set it up. The top of the rope is going to be right here. 0 to what? 30. Oh, now look at that, y'all. Now my paper is an eraser. So B is going to be from 0 to 30 because that's how much of the rope that I'm pulling up. But we've got to add something to it. We've got to add the dead weight pretty much. To send that slither up 30 foot of the dead weight plus the antiderivative from 30 to 60 of 2 times 30 dx. Now a lot of you are saying, well, wait a minute. No. What does the rope weigh? 2 pounds a foot. And how much of the rope are you going to be pulling up? How much? 30 foot. There's 30 foot of weight there, period. So all you're doing is multiplying the 30 foot times 2 pounds of what? 2 pounds per what? 2 pounds per foot. So, now what about from 30 to 60? Well, you got to remember, when you're pulling the rope is hanging off the dadgum building, right? So at this point, it's 0 feet. If you haven't pulled anything up, how much rope have you pulled up? None. 0. This is 30 feet, and this is what? 60 feet. So now I'll do part B. And then I want you to look at the answer and then think about the answer compared to A. Check and make sure nobody else is stepping in late. Watched another scary movie last night. Lights Out. That one was scary. That was scary. It's about this spirit that comes around whenever the lights are out. But it's spooky because it's got that crazy looking figure. They're in the hallway or they're in the doorway, and then when you turn the lights on, it disappears. And then when you turn the lights back off again, she's right there at your face going, ah! Huh? Then there wouldn't be a movie. It was a scary movie. It was scary. 2,700. Now, very good. I'm very proud of you. Now, what does that mean? Look at A and B.
It's not, it's not half the work, but it's a little more, it's more than that.
Why is it more work? Why is it almost more than pulling up the whole? 3,600 is pulling up the whole rope. Pulling half the rope up is almost as much as pulling the whole rope up. Why? You're pulling up the what? The bucket. You're pulling up the dead weight. So a lot of you would say the old algebra thinking would be, oh, well, I'm going to pull up half, so half would be 1,800. It'd take 1,800 pounds, foot-pounds. That's your algebra way of thinking. Right? It's not that simple. Remember me telling you a long time ago, Calc 1 students? You remember this? 2, 3, x, and the direction says find x. And the student goes, here it is. Y'all remember that? Y'all seen that on the internet? What did I tell my Calc 1 students about that? It's too easy. All right? Taking B, how much work to pull half the rope up, and if you say, let's see, half of 3,600 is 1,800 pounds, then you might as well just go ahead and just mark that one wrong, because nothing in calculus is what? That simple. It's not that simple. That's your old algebra thinking. All right? So, when you're talking about how much work to pull the rope up, you're talking about the slither, and then you're talking about work is equal to force times what? Times distance. And the distance in most of these problems will always be what? X. The force is, going to be a force, or it could be a weight. And then the slither, of course, is going to be your X. And this, you've got to think not only part A, but you also got to think plus dead weight. Now, there's a couple of problems in the homework and the test about a rope with the weight on the end of it. There's even one problem I did one year. People were hanging an outlaw. How much weight is? I got ridiculed for that. So anyway, and I didn't even write the problem. I just pulled it off the internet. I'm offended. Oh. So that's the problem there. All right? Here is the dreaded tank problem. Let's see how many pages it is. 2 pages. Now, I'll take good notes on this one, because this is where you really bog down. No, I don't want to go over the tank problem yet. I want to go over Hooke's law. Where's my Hooke's law? And before I go over Hooke's law, there we go. Hooke's law usually comes after the rope, so I might as well follow. Let me pull up We're going to go back in time now. And we're going to pull up, well, my whiteboard, and I'm going to pull up some problems for y'all. And you don't have to we're not going to work all of them. We're just going to work. I just want you to write them down. Y'all remember this from algebra? One more. Okay. All right, write those down. Hopefully some of y'all remember these words. Direct variation, inverse variation. Write those down. The formulas are at the top, and just work. We'll work the last one. Find y when x is equal to 1.5 if y varies directly as x and y is equal blah, 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 blah. Okay? Now, this is algebra, it's 100% algebra, but the reason I'm showing you this is with Hooke's law, sometimes you have to find the spring constant. And what is a constant? Well, if it takes 2 cups of milk to make 12 cookies, how many cups of milk does it take to make 24 cookies? How many does it take to make 36 cookies? Okay, what do you do with it? You're finding a constant to multiply by, right? A constant is a number that you multiply by to make the formula what? Work. So K is always going to be your what? Constant. So some of y'all that have had me before, especially in algebra, you should remember that K never what? Changes. It never changes. And I'm trying to find my, here we go. K never changes. K is always the constant. Now, you're not going to use these too much with the Hooke's law, but you're going to use this one. So you might want to write down the direct variation. This problem right here says blah, 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 blah. Y varies directly as what? X. Now sometimes this isn't going to be Y and sometimes this isn't going to be X. But which way do we read? Left to right. If this is A varies directly as B, then this A is equal to K times B. Plug in the variables as you read them. Which one does not change? The variable K will always be what? K. Because it stands for the constant, and that's what you're trying to find out. Now, y is equal to negative 16. X is equal to what? So what do? You got to find K. Divide by 6. Divide by 6. K is equal to negative what? Well, go ahead and put, go ahead and put 16 over 6 in your calculator because you need a variable. I mean, you need a number. 2.67. So now you know that K is 2.67, and you take that and plug it into your formula. Y is equal to negative 2.67 times what? X. You've used up all of this information. Now, find Y when X is 1.5. What are you going to do with that 1.5 now? Plug it in. Y is equal to negative 2.67 times 1.5. And somebody give me that negative number. I'm sorry, what? 4 even? Okay, so that's a little bit of algebra review about how to find what. Okay. And all of you should be saying, oh yeah, I remember that. Good. Good job. That's what you're supposed to say. Mr. Wisenhut, you remember that? You don't? I mean, honestly, you don't remember it at all. Okay. Okay. Well, that's algebra, math 102 or college algebra. You see them both in both of those. So go over that so we can do Hooke's law. Now, Hooke's law basically is measuring how much work it takes to stretch a spring. Let me write this one on the board. I'm terrible at writing, so I'm going to type it. A force of 10 pounds is required to hold a spring stretched 4 inches beyond its length. How much work is required to stretch the spring 6 inches past its natural length? Now, the first thing you need to do with Hooke's law, and this is in red, make sure all 1 unit. Because what is work measured in? Foot pounds. So everything needs to be in terms of feet and pounds. Is everything in foot pounds, everything in feet in this problem? No. So you need to change that. That's the first thing you need to do. Now I want you to highlight that, make sure all 1 unit, because that's the first thing y'all going to forget on a test. And y'all going to put 4 and 6 in there, and you're going to get mad when you get it wrong. And then you're going to blame it who? Russia. I haven't had a Mountain Dew and I don't know. Let's go see it. I kind of stay away from Mountain Dew because it's got so much caffeine in it. I haven't had a Mountain Dew probably since a couple of years. But I gotta have some caffeine so I don't get a caffeine headache.
I say it's bad.
Okay, I gotta worry about that. Already done that. Been there, done that. Oh well, been there, done that. So I can drink all the Mountain Dew I want to. All right. Yeah. Done. Headache's over. I've made it through without having too much gray hair. All right. So we've got 10 pounds to move 4/12 of a foot. Looks like we could maybe find a constant with that. Find a constant with it, then we can plug that in. Because work, Hooke's law says that you take the antiderivative from A to B of K times f of x dx, or k times x dx. Now, what went here with your work problem a while ago? F of what? X. Or a rate, or a force. The k you got to find with Hooke's law. Alright, so we're talking about Hooke's law here. So 10 is equal to k times 4 over what? So multiply both sides by 12, of course. And that's going to give you, well, we can cancel something out. 12 divided by 4 is what? 3 times 10 is 30. So 30 is equal to k. Well, we've got Apple problems set up. We just go over here and say A to B 30x dx. Now we just got to figure out what A and B is. Well, this is it right here. What is a spring when it's at its natural length? 0. Has it stretched any? No. Then what is the stretch length? Half a foot, right? Now do it. Let me ask you a question. If it takes 4 pounds to stretch 4 inches, how much is it going to take to stretch more than 4 inches? More or less. So it's going to be more than 4, right? So if you came out with 3.75, then you put that down on a test, and the teacher's going to think you're what? Stupid. I'm sorry, challenged. Think about it. If you put $500 in the bank in a savings account and leave it in there for a year, are you going to pull out $442? No. You're going to pull out $500 and something because they give you interest. If you pull a spring and it costs 4 pounds to go 4 inches, then it's not going to cost 3 pounds to go 4.5 inches or 6 inches. It's going to be more than 4. So common sense would dictate that your answer is going to be more than 4. Just trying to teach a little common sense. You know, it's something that a lot of people lack. So, x squared over 2, does that come out to be 15x squared? Help me out. Evaluated at 0 and 0.5, or 1/2. I'll do the 0 for y'all. 0 comes out to be 0. 15 times 1/4 is equal to 15 fourths. And 15 fourths is equal to what? Well, it came out to be less than 3. I must have had I had it pass after the 3.75. I thought it was more.
Wait. You have to bring up you said it will not be
Because you have to make everything what? I know, I had to pass backwards. It's supposed to be less.
You take less what you said you farther?
But you're only going 2 inches more.
Oh.
Think that you got to. I know. I put that right. I should have said what I said because now you're thinking about the opposite. If you got a spring, and let's say this spring is right there, okay, and it takes 4 pounds to stretch it 4 inches. 10 pounds. I'm sorry. That's right. 10 pounds. 10 pounds to stretch 4 inches. Then to stretch it 6 inches, which would be just 2 more inches.
Oh, it's, because it would actually,
Be 3.75.
13.75, if you just do it with that, that say how much more.
Technically, yes. It takes basically three and 3¾ more pounds. Okay, that's what it's saying.
What you said, what it says,
Mhm.
it just was. Did you say
No, that's one of those book like problems. Yeah, it takes probably around 14 pounds. Okay, so that's Hooke's law. And like I said, there's 2 or 3 things when you're dealing with Hooke's law. The first thing you got to do is to make sure all is one unit. Second thing you do is find what? Find K. And then once you find K, and you have this, you just plug and chug. You got to make sure that these are units. The units are all the same. All right, let me give you a nerd.
That would be a good reference.
Yes. Two joules of work is needed to stretch a spring from 30 centimeters to
Ahmed says he can't see the screen for some reason.
period. How much work is needed to stretch spring from 35 centimeters to 40 centimeters? Now this one you're going to work with K in the integral because it's asking about joules for one thing, and it's also giving you 30 to 42 centimeters versus 35 to 40 centimeters. So 2 is going to be the work. So 2 is equal to an antiderivative of something. Okay, because they're giving you the work here. So 2 is equal to the antiderivative of something, something, something from something to something. And that's when K is part of that.
Oh, Mr.
You gotta
Hubert.
find K. So K is going to be a variable in the integral.
Oh, Mr. Hubert, I can't see the screen for some reason.
And I'll give you a hint from 0 to 0.12. Why is it from 0 to 0.12? No, this is well, yeah, you're assuming that 30 is at rest. Yes, not yes. So what's the difference between 30 and 42? 0.12 centimeters. And yes, you have to change, you're right. you have to change the 12 centimeters into .12. Because joules is measured in meters. And that's for y'all's physics people. It's been such a long time since I played with joules, I don't even think it's Joules. And I'll probably depend on Jeopardy to remind me about that. I record Jeopardy, I love Jeopardy, so I watch it every night. Right now is the college series, which I'm waiting for the math, but they never put math on there. Two subjects they never put in Jeopardy categories, hardly ever. The Bible and math. Every blue moon, they know how dumb America is, huh? No, they do not.
I think it's better to do more of that stuff.
Yeah, because America's stupid. America knows more about Kim Kardashian than they do about their own, how to add fractions. Huh? Yep. Damn Russians. And then hacked into Jeopardy. X dx. Now solve it. Any vodka in that bottle? Okay. That's one side. That's one. I can't drink that stuff. I think that's about that and gin, because gin smells like pine salt. And every time I smell it, I just. And it comes in a green bottle, just like pine salt. Or Texas, or whatever. Isn't gin made for pine cones? Huh? Rum comes from sugarcane. Tequila comes from the guave. Bourbon comes from grain. What does gin come from? I thought it came from pine cones. That's why it stinks. Look it up. And why do they smell like pine cones? What's juniper berries?
It's berries from a tree, so it's supposed to like those.
Huh?
It's the berries from a tree. So it's supposed to like those.
Yeah, it could be pine cones. Somebody had food. We'll go downstairs and see if they're giving away food. Usually that's what that means. Yeah, that's true. What'd you say? We do that on the 20th. You're supposed to go by and speak to your advisor. That's what I talk about in the class. I spend the whole class talking about that. Did anybody see what went on at the White House yesterday?
Priority 1 message coming in on secure channel.
It was easy. It was interesting because the Israel president Netanyahu came to the White House, and I put a post saying it's good to see the Israel president coming to the White House and being welcomed, and some guy ripped into me and called me a racist. And I'm like, how do you even? I think he was crazy. I think he's got some kind of issues going on because he's. I mean, his post made no sense whatsoever. Let's see if I can find it. Yeah, it made no sense whatsoever. Wish I could find it, but I don't think I can find it.
Was it the post that you said, the president of Israel said that, our alliance with Israel would be stronger than others, something like that?
Yeah. Or something like that, and the guy came on there and he says, I'm sorry to tell you, Brother Marine, you have a racist attitude. And I swear I'm trying to find it because I can't figure out how welcoming, and says visitors from the U.S. come by Congress, not by President. And I'm like, what the hell is he talking about? So I didn't reply, and some guy, this was on a national post. It wasn't on one of my local. It was on, a national. And one guy from Texas said, "What the hell?" Put WTH ? And it was just awful. I'm gonna tell you something. You comment on some of the national posts, you're gonna get some crazy people out there that have no idea. You have no idea what they're talking about. Anyway, 2 is equal to what? What's the
What's K?
K?
6?
Well, K x squared over what? 2, and that's evaluated at 0 and 0.12, and then 0, of course. If you evaluate this, the 0 is going to go out, so that's not a factor. 2 is equal to K times 0.12 squared over 2, and divide both sides by 0.12 squared over 2, 0.12 squared over 2, and what does K equal? Just say 278 is good. I think mine came out to be 277.78. Let's raise it to 278. All right, so now you found K. So now W is equal to 0.05 to 0.10 of 278 x dx. Now, what's the difference between 30 and 35? 5, Hubert. That's right, class. And 5 centimeters is 0.05 what? Meters. And then what's the difference between 30 and 40? 10. So 0.10 would be that. So you got to be careful how you do this one, because this one is a little bit different. The question is set up a little bit different from the first question. And the way that you're going to discern this is by, starts with P, R, A, C, what's that word? Practice, yeah. By I assign you problems and you do them at home, homework. So, 278x squared over 2. evaluated at 0.05 and 0.10. And what does that mean? You know how to do this. So 278, I'm just going to pull that out. 0.10 squared over 2 minus 0.05 squared over 2. That's 3 dots. And I came out with 1.04 joules. It's around 1.04. I used 277.78 or something like that. And I came out with 1.04. Somebody used 278, what do you get? Okay, you still get the same? Okay. Well, I'll take you get around 1.04, I'll count it right on test. I won't really care about the decimals. And that's Hooke's law. And now that leaves us with the tank problems. Now I'll be honest with you. On a test, if I give you 10 problems, 8 of them are going to be tanks. One of them is going to be a hook, and one of them is going to be a rope. I don't care about the rope and the tank and the Hooke's law. And if I choose a Hooke's law, it's going to be like the first one. It's going to be one that's pretty straightforward. I'm not going to put a hook on top of a spring on top of a building and stretch it with a 15-foot weight and ask you where the hook was made, where the spring was made. I'm not going to ask you anything like that. All right. The tanks, you're going to really get tired of tanks before next week. After next week, you're going to get tired of it. Okay, and that's what you're supposed to do. But Miss Sheep, what did y'all get tired of working with last time? Related rates. But do you remember them? Yeah, you do. All right. So let's do one. Now I'm going to have to use my artistic abilities here. So that means it'll take me about 30 minutes to draw a cone. There we go. Handy dandy straight line maker. I do that every single time. Hit the dang button. There we go. Alright, there's your cone. And I'm going to draw another there. Actually, I'm going to change that. I like that. I want to make that. Wish I could make it gray, but I can't. Make it a real light color yellow so you can barely see it. Because I don't want you to see it too much. There. And then it's half full of OIL. So I'm going to put a thick circle right here. It's supposed to be black. Told you it'd take me 30 minutes to draw this. And then I'm going to put a bunch of stuff up here. Let's see. The height of the cone, conic tank is equal to 20 meters. Diameter of the conic tank is equal to 25 meters. half, no, height of OIL is 10 meters. OIL density is equal to 800 kilograms per meters cubed. You might want to highlight that because you're going to see that a good bit. How much work to pump OIL out of top of tank? And it's assumed that there's a little hole at the top of the tank and that you're pushing it out. Now again, you got to remember you're thinking about the little plunger. Remember your push up? Okay, this is a push up, and this little thing right here is your push up on the stick, and you're pushing it up. So it starts down here. And it starts so small that you can't even see it. Okay? It's like down here. And as we talked about the other day, what happens to the radius as you push it up to the top of the cone? It gets what? It changes, yes, it gets larger. So one of the first things you got to do is find out that relationship. Now, also, I will be glad to give you the formula, because remember I told you on these, chances are the formula is what you're going to be using. So V is equal to pi r squared what? H. Now see what you can come up with now. Finish drawing your picture, label your picture. All right, I'm going to do that because it does help to label it, especially with your yellow radiuses there. Okay, we know this is 10 meters of OIL. And we know this is 20 meters. And we know this is 25 meters. Now your first objective, and I'm going to write this in yellow, not because you can't see it, because you need to think of this plunger. This plunger is your main objective in starting this problem. You've got to figure out the relationship from the radius of this yellow circle to the height of this circle of the conic section. So you should be saying to yourself, well, we've got a 25 across there with a 20 versus R over H. Set up a what? A proportion, Hubert. That's right, class. Okay, so your first objective when you're talking about a conic section is to find out the related rate of height to what? Radius. Good. You're paying attention. objectives. Find R arrow H related rate. Because the height to your plunger relates to the rate of your it's related rate to the radius of your plunger. So 25 is the
Priority
20
one message coming in on secure channel.
as what? 2R is the what? H. Solve that. Now, do you want it in terms of H or do you want it in terms of R? You want R equal to H because you've got to plug in H where? Okay. So, $25H is equal to 40R. Divide by 40, divide by 40. R is equal to 5 will go in there. What? 5/8. Somebody help me out. 5/8 H. Is that what everybody got?
And so, ratios, the height of the diameter of the total.
Yep. Okay, now plug that into the formula. Y'all got it written down. All right, 2. Plug into the formula. So, the formula, and this is for the volume of the slice. Remember, everything is focused around the slice. And this plunger is your slice. That's the slice. Now, what's the width of this slice? Well, the width is the width of a hair, okay? But we call it dx. Now, the volume of the slice, and when you're dealing with metric, you've got to find the volume of the slice and the mass of the slice. Why do you have to find the mass? Because you're dealing with the 800, well, it's in that list, 800 kilograms and all that. And then the force of the slice, and then the distance. So the volume of the slice is going to be equal to pi 5/8 H, quantity squared, delta H, which at delta H, that's going to become DH. It's supposed to be an H in there too, right? Pi r squared, what?
Priority 1 message
Pi r
coming
squared
in
H
on
and the H
secure
is
channel.
delta H right here. Okay, my bad. And then that comes out to be pi 25 64ths H squared DH is what it's going to come out to be. And that's the volume of the slice. Yes, because it's the height of this, that little piece right here. The mass of the slice is equal to the 800 times this. What you're doing is you're building your antiderivative is what you're doing, using the volume, mass, and this force. When you get through, all you're going to do is put an integration symbol in front of it and do it. So 800 times all of this. Pi 25 64ths H squared times DH. And then the force, you've got to add the 9.8 because it's in metric. Yep. What? Yep. And then the distance, 5, and this is very important. The distance on your conic tanks is going to be, hold on, let me show it to you, because distance of your slice is equal to, what is the total distance of the tank? And what is the height of your slice? So what is the distance of your slice? 20 minus what? H. Now that's very important because most of the time your distance is going to be something like the total minus H. And now you take these two and integrate. From 0 to 10, because that's how much liquid you have. From 0 to 10. So the work is from 0 to 10 of all of this trash. 9.8 times 800. Of course, what are you going to do with all this stuff? Some of it you're going to what? Pull out. Take your highlighter. I want everybody to take your highlighter right now. And I want you to highlight this. Because this is what you consider the what? The setup. Which a lot of homework problems and a lot of test questions We're going to ask you for it. The first thing you find is your relationship. The second thing you find is your volume. Third, math. And this part right here is building the guts of the what? Of your integral, of your setup. Okay, that's building the guts. When you're doing a conic section, you have to follow the same type. Now, you may want to turn some things around and do it the way you want to do it. That's fine. But you have to get something consistent, and you have to get this branded in your brain on how to do the conic tank. Because you're going to follow the same type problem throughout. Now, if you want to do the integral, basically what are you going to do? You're going to pull what out? You're going to pull the 9.8 out. You're going to pull the 800 out. You're going to pull the pi out. You're going to pull the 25/64 out. And that leaves you with 0 to 10 of 28 squared minus what? And Miss Sheep, you eventually get your h cubed in there somewhere. Either now or later, you eventually get it in there. All right, now finish it. And you can pull 20. Did I not do it right?
Priority 1 message coming in on secure channel. Put down 40 million joules. That's what I came out with. Now, of course, it's not 40 million on the money. It comes out to be 40,088,031 joules. If you come out with close to 40 million, you're on the money. Okay? Now, the difference between this problem and the next problem is the next problem is a cylinder. Now, what difference would that make? The radius doesn't change, so what kind of problem would you like on a test? Cylinder. No. I'll put probably 2 or 3 cylinders, 2 or 3 conics, 2 or 3 inverted cylinders, or a trough. So I'm gonna challenge you, but you're gonna get the challenge in the homework. Okay? Let's put the next one up. Did you get 40 million? Anybody check it? Oh, okay. Well, should be around 40 million. Now let's try nerd. And then, of course, next week we'll go over more problems. I'm just showing you the surface, and then y'all will get the homework and you get discouraged, and eventually you'll what? Quit. Good. At least we got that down. All right, here we go. You got 40 million? Good. Well, I don't want that to be. So let's change that to black. You're supposed to change to black when I tell you to change to black. You know, it'd be nice to have training. All right, there we go. Thing on top of the cylinder. Y'all impressed, aren't you? I don't know how to do. I don't know how to bring it back in now. I guess I'll have to bring it in this way. No. Give me a second. Y'all are impressed. I know. Copied my dang old image. Did that without training. Yep, I didn't go that day. What day? We never had training. Alright, there's my cylindrical tank. And where's the information? This thing is slap full of H2O. And we also got a little pipe coming out the top, which is not a big deal, but will be on the distance. So I need to put a little there. Now this distance I'm looking 27 feet. Couldn't find the distance, it was covered up. 27 feet. What kind of unit is this? Standard units. So that means less work. Tank full of H2O. H2O equals 62.4 pounds per cubic foot. That's a good number to remember. I've actually used this on the farm. I had a tank of water that I needed to take. I needed to fix a tank of water because sometimes the pond at the hog parlor or the hog pen gets too low for the hogs. And the pens that I have them in that encompass the water on the shore, it gets down and they can't get water. So I have a water tank that I take down there and I put in their troughs, put water in their troughs twice a day whenever it gets to be a drought. I needed to figure out how much the water weighed to see if my Bobcat would pick it up. And it was a cylindrical tank, and I had to figure it out, and I had to multiply it by 60 pounds, and I just did it by 60 because I didn't care about the 62.4, because I wanted to see if it tipped over the Bobcat, which it didn't. But The whole point is at 60 pounds per cubic foot, once you find out the volume of the tank, you multiply it by 60 to see how much it's going to weigh if you pick it up. So very applicable stuff. And you also do it if you was to design a spray tank on the 3-point hitch of a tractor. That's one of the weaknesses of the 3-point hitch sprayers way back in the 80s and 90s. Whoever designed them didn't do the math right, because the water would break the 3-point hitch bracket, and you'd have to get it welded and get it fixed, because whoever, I don't think probably even did the math. I really don't, because it never did work. We bought 2 tanks in the 80s and 90s, and both of them broke because they didn't do this. So anyway, always remember that water weighs about 60 pounds per cubic foot. That means 1 foot cubed weighs about 60 pounds. And I think OIL, I think it weighs twice that much, or I think 90, somewhere around 90 or 100, because it's more dense. So it's kind of nice to know. The radius, or the diameter, is 16 foot. Now, I want you to take what you learned from the previous, and don't worry about the radius, because the radius don't change, so you don't have to do that step. So now you've got to set up the volume of the slice, and that's pi r squared h, right? Ain't that cylinder, pi r squared h? So set up the volume of the slice, the force of the slice, and the distance. Well, what's the distance going to be? 30 minus what? H. I can tell you that right now, because the height of the tank with the spout is what? 30. Distance also means displacement. Where it moves, where the liquid moves. The liquid moves not 0 to 27. The liquid moves from 0 to what? 30. So that's distance, 30 minus h. Now let me ask you this. Like you push up. Where is the push up going to go? As far as distance wise? It's going to go up, yeah. But from where to where? Push up. No. Push up. Why not 0 to 30? It can't go in a little spout. So the integral is going to be from 0 to 27, because that's where the liquid moves in the tank. Remember, your integration, A to B, is going to be where your liquid moves. Liquid. Right? Not the distance. That's a common error that students make. They go 0 to 30. No. It's not right. Huh? 30 minus h, the distance of your slice. Because the slice can continue to go through the the liquid moves, yeah, the slice is 0 to 30, so it'll be 30 minus h, because the distance that the liquid travels is 30. So, the volume of the slice is equal to pi 8 squared dH. And then the force of the slice is equal to 62.4 times pi 8 squared dH. Now, why do we not have to multiply by 9.8? Because we're in standard units versus what? Metric. What's your question? Okay. What, you wonder about 9.8? 9.8 is only with metric. And then the distance of the slice is equal to 30 minus h. Now, here is your what? What is that? Here, what is that? Force and the distance. Work is equal to force times distance. You'd be surprised at how many people don't see that until I point it out. Force times distance. Set up your integration and tell me what you come out with. Say again? Well, a lot of it's going to come out. The 62.4, the pi, the 64, all that's going to come out, and you're going to be left with 30 minus h dh. Wait a minute, there should be an h squared in there too. I skipped something. Hold on. Right here. Should be an h squared. I left out the h squared. What'd you say, Mr. Wissenham?
What is the distance of the slice? 7
I'm sorry. Why is the distance what?
The distance of the slice. Why is it 30 minus
Because of the spout. Now, yes, yes, but the distance from it's hard to explain. It all has to do with the traveling of the liquid.
It's not really the distance of the slice, but it is
You can't, yeah, technically it's the distance of the liquid, but the slice is the liquid. Okay, the slice, just do not, yeah, that's one of the biggest problems with the spout. If I was to leave the spout off, you'd do it with no problem. But remember, when you're talking about the spout, okay, the liquid travels through the spout. So you have to incorporate that in with the
distance of the work.
yes, you could say displacement. And maybe if you want to use displacement, that works better because the OIL or the water moves from the bottom of the tank to the top of the spout. You might want to think of it like that, displacement. I never thought about that. So, the
Does the volume of pi r squared?
hold on. I don't have a. Where did I get that? Oh, I'm sorry. I looked at the wrong problem. I'm sorry. From the previous problem, my bad. No, I'm wrong. I looked at the wrong paper. Let's turn this over. There. So we've got the antiderivative from 0 to 27 of mess 62.4 times pi times 64 times 30 minus h dh. And of course, this is the setup. when you do the math, $5.5 million foot payments. If you got anywhere around 5.5 million, you're good to go. 5.5 million foot payments. Which a lot of you are saying, good gosh. Take a 55-gallon drum and fill it up with water and see if you can pick it up. It's hard to pick it up. Not to mention if it was OIL or diesel, something a little bit more dense, you can't move it. I know I picked up a diesel tank one time with the front end loader on the farm, and I found out how heavy it was because the front end loader, the back of the tractor went off the ground and scared my mule. Okay, I was pretty scared. I was only like 9 or 10 years old, and I picked it up, and my daddy told me to move it, but he didn't think that it was full of diesel fuel. So when I picked it up, of course it wouldn't have hurt me because the tractor just went down enough to where it was sitting on top of the front end loader was sitting on top of the diesel tank, but it still scared me. But liquid weighs a lot. That's why we have hydraulic jacks. That's why we have hydraulic cylinders, because try to compress a liquid. Try to. You can't do it. I mean, if you think of the power behind a hydraulic pump or a hydraulic jack, I mean, hydraulics is what works your brakes. That little 3/8-inch rubber line that goes from your brake line, your brass brake line, to your brake caliper, you're talking about all kinds of PSIs there. And that is nothing but liquid hydraulics. Of course, if there's a hole in your little 3/8-inch rubber hose, then you'll be dead. But nobody ever thinks about that. That's why they go 100 miles an hour. All right. So who's got questions on that? Did y'all come out with 5.5? What did you come out with exactly? 5 point what? So it's 5.5? Yeah. If you said 6 million, that would be good because that means you're overcompensating. So that means that your pump, if you're overcompensating and you rig the pump to do 6 million, then the pump won't burn up because you're overcompensating. Engineers always overcompensate. So the answer here, if you're an engineer, would be 6 million foot pounds. Okay? Question. So your 10-year-old son don't collapse the front end loader. All right. I don't have any idea what time it is. What time is it? Okay, well, it's time for y'all to go. Let me call the roll. We only got like half the class here. I don't know where the rest of the class is. They're not Skyping. There's only 4 or 5 Skyping. Russians must have kidnapped them. Huh? All right. Who's here? 141.
We have another test soon.
Well, after this, yeah. Okay, Ahmed is Skyping. Anderson is here. Bradshaw, is he here? I don't think he Skyped today. Edwards is here. Grant is here. Huth, I don't know where Huth is. Khalil is Skyping. Nabay is here. Patel is here. Peter is Skyping. Scobie is Skyping. Sheik is here. Silver is here. Thompson.
Here.
Is Thompson Skyping? Let's see. Thompson, yeah. I can't hear anybody. Who turned it off? Whose speaker's off?
Yours.
No, that's video camera.
No, yours is
This side
off.
Where?
Physical speaker.
Stupid. Now you can talk, Mr. Thompson.
Oh, can you hear me?
Yeah, now I can hear you. Thank you. Stupid Russians. All right. Thompson, Tucker. Did Tucker, is she? Let me look and see if she's here. I don't think she's. Nope. Tucker's not here. Quisenhunt's here and Williams is Skyped in. All right. Y'all have homework to work on with these work problems. I did put work problems up, didn't I? Oh, I put more later rates. So now I get to put the work problems up. Okay. I'll do that now. See me on test questions if you got test questions. Mr. Wisenhunt, I know you got one. Rest of y'all have a good weekend. Skype people have a good weekend.
You too.
See y'all.